we'll go ahead and get started. And so we're going to try to finish up 2.5, which shouldn't really take that long to finish up. And then we'll look at 2.6. And if we have time, we'll look at some of 2.7 as well. So let's go ahead and finish up 2.5. Now, what we've covered in 2.5 is we looked at how to find the equations of lines when we had 2 points, when we had a point and a slope. Now we're going to use that third page in your flowchart. And that is when you have a line equation and you have a point. And they're either going to be parallel or they'll be perpendicular. So we'll start off with this question, and you can either write your answer in standard form or slope-intercept. So we'll do one in standard, one in slope-intercept. So let's say you're given this line equation, which is y minus 2x equals 4, and it's got to pass through 5, 6, and we want it to be parallel. And we're going to write our answer in slope-intercept form. So the first thing we need to do is we need to find our slope. So the first thing we do is we take our equation and we solve it for y. So we have y minus 2x equals 4. And so we're going to add this 2x to both sides. And then we're left with y equals now 2x plus 4. And that 2, when we've solved for y, that represents our slope. So our slope in this case is 2. Now, we want it to be parallel. And so what does it mean if they're parallel? Well, parallel lines, like we talked about before break, they have the same slope. So parallel lines are going to have the same slope. So we're going to use that slope. So we'll use that slope of 2 with our ordered pair, and we'll use that in our point slope formula. So we've got our slope. So our slope is 2. And we're going to use that point 5, 6 that was given. And we're going to use this in point slope. And that's y minus y1 equals m times x minus x1. And again, this is x1, y1. And we've done these type of problems before from here. So we should be able to quickly plug our values in. And we're going to get this in, again, slope-intercept. So we'll be solving it for y at the end. So that gives us then y minus 6 equals 2 times x minus 5. We'll distribute that 2 through. So we'll distribute that 2 through. Find a better marker, maybe. So we'll distribute that 2 through. And that's going to leave us then with y minus 6 equals 2x minus 10. We'll add our 6 to each side. And now we've got our final equation, which is y equals now 2x minus 4. So that is going to be our answer in slope-intercept point. So pretty simple. Follow the directions, follow the flow chart. Let's do one more of these. This one's going to be perpendicular. And then we'll look at 2, 6, and 7. So let's say let's say you're given an equation. And let's say you're given this equation 3x minus 5y equals 2. And we want it to pass through this point, so pass through the point 4, 1. And we want it to be perpendicular. And we also want this in standard form. So just like the last equation. So what do we do first? Well, we have to come up with a slope. Okay, so that's our first step is to get that slope. So we take our equation and we solve it for y. So we move that 3x over with subtraction. And we now have minus 5y equals a minus 3x plus 2. Then we divide everything by that negative 5. And now we can get our slope. So now we have y equals negative and negative here makes it 3/5 x. Positive over negative makes it a minus 2/5 on the end. That 3/5, that's the slope. We're not going to be using that. In this case, what do we want? Well, we want the perpendicular slope. Very important that we follow the directions here. We want the perpendicular slope. And for the perpendicular slope, we use the opposite or the negative reciprocal. So for perpendicular lines, we use the opposite or the negative reciprocal. So we're going to be using then minus 5/3. We flip the fraction over and we changed our sign. So that's the slope that we're going to be using. Now we've got everything that we need. We've got a point and we've got a slope. So now we use our slope, which is minus 5/3, with that point 4, 1. And again, we use the point slope formula. And that's y minus y1 equals m times x minus x1. We plug our values in. So that's y minus 1 equals minus 5/3 times x minus 4 here. And this is just algebra from here. We distribute that negative 5/3 through. Then we'll clear our fractions. and we'll get it in standard form. So let's go ahead and distribute through first, and we get a minus 5/3 x. Double negative makes it a positive. 5 times 4 is a 20 over 3. And we do want this in standard form. So standard form, we cannot have fractions. So we'll clear out the fractions by multiplying it all by 3. So we'll multiply everything by 3. Find the marker that actually works here. So multiply everything by a 3. And when I multiply it all by 3, that gives me 3y minus 3 equals minus 5x plus 20. And we want this in standard form, so that means the x and the y's are on the left. Numbers go to the right. So we'll add our 5x, and we'll add our 3 as well. That gives us then our final answer, which is 5x plus 3y equals 23. So that is going to be our final answer right there. Okay, so that's our final answer, and that's in standard form. And that now should finish up 2-5. 2-6 and 2-7 kind of go together. And we're going to look at 2-7 first because they're kind of in opposite order of what I think they should be taught. So we're going to look at 2-7 first, and then we'll come back and we'll look at 2-6. But 2-7, I think, needs to go first. And we're going to be graphing. We're going to be graphing things that are not lines. So these are going to be curves. We graph them kind of like we graph lines. And this is very easy as long as we use the common graphs. And these are in the back cover of our textbook here. So all these graphs, these are the ones that we're going to be using. Now what we do is we identify which one it is. And that's based upon the operation that's involved with the x. So the first one is just the identity. And these are all in the back cover. And the first one's just an identity, and that's a line. We've already covered this one. Then we've got the square. And so if our equation has an x squared in it, we use this squaring function. So it makes a u. The cube looks like this. The square root looks like this. Cube root looks like this one. Absolute value is here. And we'll come back and get the greatest integer in a moment, because that's actually in 2-6. But I think these are easier to work with than the ones in 2-6. So we're going to do 2-7 first. Then we'll come back and do 2-6. Because, again, I think they should be put in the opposite order, but our textbook switches them around. So we're now going to look at 2-7 first. And we're going to be learning how to graph these functions. And these are no longer going to be lines. So I'm going to give you a function, and we're going to learn how to graph it. And again, these are very, very easy. It builds on what we just learned with how to graph lines. So let's try and graph f of x equals 4 square root of x. Now, what we first look at is we need to figure out what does this graph look like. So we look at the operation that's involved. So what's involved with that x? It's got a square root around it. So this is going to be a square root graph. And what does the square root graph look like? Well, if you look in the back cover of your textbook, it's going to look like that. Now, what about that 4? Well, that 4 is in front, and that 4 is just like your slope. So it's going to behave like our slope. It's not really the slope, but when we go to graph these, we use it in the same way. So this is like the slope. Now, looking at this graph, where do we start at? Well, there's no number on the end. So we start at the origin, at 0, 0. So we start right here at 0, 0. The number in front is that 4, so we're going to write that as a 4 over 1, and we're going to go up 4 units, and then we're going to go over 1 unit. So we're going to have to go up 4, and then we're going to go over 1. And then we make our new dot. Now, normally we would just connect them together with a straight line, right? That's what we've done. But in this case, we want it to look like this curve. So we want it to look like this. So it needs to curve a bit. So when we connect them together, we curve it instead of using a straight line, and that makes your square root graph. So what did that 4 in front do? Well, all that 4 in front did was make it 4 times as tall. So we identified what graph we're using. Then we looked at the number in front, and that's going to behave in a similar manner to your slope. We plotted our point to start with, which in this case was 0, 0. We went up 4 over 1, plotted the next point, and connected them together with a little bit of a curve. Let's try another one. Let's try and graph this one. Let's try and graph f of x equals minus 1/2 absolute value of x. Once we get these down, then we'll look at how to move the graph around. Move it up and down, left and right. We need to make sure that we understand the basics first. Now, what should this look like? Well, if we go back and we look in the back cover of our textbook again, and we look at the absolute value, because that's what we're working with, the absolute value looks like a V, doesn't it? So that's what we're going to be using, and we're going to be basing our graph on that V. So it needs to look like this. This is the absolute value. And the absolute value makes a V. What we have to be careful of is that 1/2, that minus 1/2 here. So when we go to graph things that are not functions, to make sure that they look correct and are not distorted, if it's a fraction, it has to be over 1. So we're going to use a minus 1/2 over 1. Must be over 1. If you went down 1 and over 2, your graph would be distorted a bit. We don't want that. So if it's a fraction, you put it over 1. Now, this one has a negative in front, so it's going to go down. So it's going to be a V opening down. Okay, we had to make that minus 1/2 over 1. It has to be over 1. So if it's a fraction, you always make it over 1. Otherwise, your graph will be distorted. There's no number on the end, So we start right here at 0, 0. And what are we going to do? Well, we've got minus 1/2 over 1. So we go down about a half and over about 1. So we'll go down just a little bit here. So we're going to go down just about a half of a unit. And then we'll go over 1 unit. And then we'll make our dot. So we went down a half and over 1. This one is not a curve. This is a straight V. Now we only have half of it right now. So when we connect these together, that makes half of it. Okay, so we need it to look like this. We have half of it. How do we get the other side? Well, we go back to our original starting place, and we go down a half, just like we did a moment ago, but we go back 1. And that makes a dot over here. And that, when we connect them together, makes the V. Why is it upside down? Well, the negative in front flips that graph over. So that graph gets flipped over. And what did the minus 1/2 do? Well, normally, if it was just upside down, it would look like this. What did the minus 1/2 do? The minus made it flip over, so it's an upside down V, and then the half makes it a little bit wider. So that's what your graph will look like. All of these so far, we have been starting at 0, 0. The next one that we're going to look at, we're going to be moving it up and down. And then once we get that down, then we'll look at how to move these graphs left and right. And then finally, we'll put everything together. And again, these are not that difficult if you just follow the graphs in the back cover. So let's look at one that's going to make it shift around. So let's try and graph now f of x equals minus 2 x cubed plus 4. So first thing we do is we identify what it looks like. So what operation do we have? That's the first step. It's a cube. Okay. So what does a cube graph look like? Well, we go to the back cover. We look here in the back cover, and we have a cube. And the cube function looks like that. So it makes kind of an S type of shape. So that's our basic graph. So this is the cube here. And the cube graph looks like this. And these do not have to be perfect graphs. All these are just simply sketches. Okay. Now, what's happening to this graph? Well, this minus 2, that is like the slope. So that's going to be minus 2 over 1. So we're going to have to go down 2 and then over 1. Now, what's new is this 4. And this 4 is located on the end. And that 4 is on the end, and it's a positive 4. So that means we have to move our graph up 4 units. So instead of starting at 0, 0, we're moving it up 4. So we're going to have to start at 0, 4. Because that 4 on the end is the y component. So we're going to start this graph at 0, 4. So we start up 4 units. 1, 2, 3, 4. And I always like to label this point so we know where we're starting it. So that's our basis, our starting point. Now we have that negative 2 in front, and so that's a minus 2 over 1. So we go down 2, and then we go over 1 from that point. And that makes another dot. We look at our graph, and our graph is not straight lines anymore, it's curves. So we don't connect them together with a straight line, we connect them together with a curve like that. Now, we need our graph to look like what? This. Ours is upside down, and why is ours upside down? Because of the negative 2 in front, so that flips it over. So we have half of it. It's not going to be down here, because see, that would make a U. And we don't want a U, we want this. So we go back to our original starting point at 0, 4. And then what we're going to do is we're going to go down 2 again. We're going to go, or sorry, we do the opposite. So we want to make sure it doesn't make a U. So we know our point is going to be up here. So we have to go up 2 and back 1. So up 2 and back 1. That makes that second dot. And now we can connect it together. And that makes our picture. It should be a little bit of a smoother line, but it's hard to draw things when you don't have a grid. Now your homework has that grid. So that grid will help you draw these better. Let's try one more of these, and then we'll learn how to move it left and right. So let's try to graph this one. Let's try to graph f of x equals, how about 4 times the cube root of x minus 2. Okay, so this is a cube root here. So what does the cube root graph look like? Well, it looks kind of like a square, or sorry, a cube. Right? It looks kind of like a cube, but the cube root is a little bit different because it's more on its side. So our cube root graph looks like that. So these pictures tell you what it should look like. So our graph, when we're done, should look something similar to that. Are you with me so far, Nick? Now, where do we start at, and what's in front? Well, that 4 is in front, so that means we're going to have to go up 4, right, and over 1. And then what about this negative 2? Well, that's going to force it down 2 units. So we're not going to start at 0, 0 anymore. We're going to start now at 0, negative 2. Because that's going to move it down 2 units. So first plot our point at 0, negative 2, which is right here. And then we're going to have to go up 4 and over 1. So we're going to go up 1, 2, 3, 4. So we're going to go up 4, and then we're going to go over 1. Make our dot, connect them together. Now we don't connect it like this, it needs to look like this. So we connect them, we kind of make it curve similar to that. And so it's not going to go straight up because that would make it a cube. Ours is a cube root, so it needs to curve more like this. So that's that piece. Now we want it to look like this. So what do? Well, we go back to our original point at 0, negative 2, and now we go down 4 and back 1. And that makes another dot here. So down and back. And when we connect it together, we now end up with our graph. That should be this point here. It should look like that. So what happened to our basic graph? Well, we slid it down 2 units, didn't we? And our basic graph, the basic cube root, looks like this. But what happened with ours because of that 4? Well, because of that 4, it's 4 times as tall. So it's the same graph. We moved it down 2, and then it's 4 times as tall. Are you with me so far? So they're pretty simple once you get the general idea. Students sometimes struggle with this, but then once they see how to use the table, the graphs in the back cover, and understand the translations, it's actually very easy. So let's try to graph another one. And this one, we're going to learn how to move things left and right. So let's try and graph f of x equals minus, let's say, how about 1/3 x minus 5 inside the parentheses quantity squared. Now, how is this different from the others? Well, the others, we had our number just attached on the end, right? We just added on the end. So here's what we know so far. The number in front, that acts like the slope. Numbers on the end. Well, if the number's on the end and it's positive, that moves it up. If it's negative, well, that moves it down, just like we looked at a moment ago. So if there's a number on the end, it moves it up or down. Positives go up, negatives go down. This, though, is different because this one we're looking at a number inside the operation. And that means it's inside a square, underneath the root, inside an absolute value. And those move it left and right. And it's the opposite of what you think it should do. So positives actually move it back to the left. Negatives are going to force it to the right. So when we look at this function, what should it look like? Well, this graph is an x squared, so it should look like this, right? Because it's a square, so it makes a u. You understand that so far? So the square makes it a u. This minus 1/3, remember, it has to be over 1. So we're looking at minus 1/3 over 1. And this negative 5, well, that negative 5 is inside the operation. And if it's a negative inside the operation, negatives are going to move it to the right. So that negative 5 is going to shift the graph 5 units to the right. Now, there's no number on the end, so we're not going to move it up or down at all. So where are we going to actually start at? Well, we are actually going to start at positive 5, because we're moving it over to the right, positive 5, 0, because that moves it 5 units to the right. Remember, x is left and right, y is up and down. So that 5 is a negative value, and it's the opposite of what you think it should do, so it moves it to the right. So we are going to now start at 5 0 here. So we'll go ahead now and plot our point at 5, 0. So that's where we're going to start. Now remember that minus 1/3, you do not want to go down 1 and over 3, because that'll make your graph look distorted. So we have to go down 1/3 and over 1. All the fractions have to be over 1. If they're not over 1, your graph is going to be distorted. And we don't want a distorted looking graph. It'll be way too wide and it won't look right. So you have to make that fraction over 1. So what do? We started our point 5, 0, and we're going to go down about 1/3 and over about 1. So down about 1/3, over about 1. And what does the graph need to look like? Well, let's go back and make sure we know it needs to look like that. Ours is going to be flipped upside down. Why is ours flipped upside down? Because the negative's in front, isn't it? So that makes the graph flip over. So we have to go down about 1/3 and just kind of approximate over about 1. So down about 1/3, over about 1, and then we connect it together with a curve. We need to get the other side. So what do? We go down about 1/3 again, and then we go over about 1. And that makes the other side. And so then we can connect it together and make our U. So that is what our graph will look like. And I know it's hard to graph that 1/3, but you're going to go down about 1/3. So just a little bit down and then over about 1 unit. And you do it on both sides, so you get the 2 dots here. And then we know we need to make it a curve, make it a U. This is going to be upside down because it's negative though. Now let's work with a couple of these where we have everything put together. So let's try and graph a couple more of these. And this is going to have everything. We're going to move it up and down, left and right, either expand or contract it as well. So let's try and graph f of x equals, how about the square root of x plus 2, and that 2 is underneath the root, minus 8. And if there's no number in front, just like we did with lines, then we can just put the 1 there. So if there's no number in front, you can just put the 1. So let's go through what we've got. What does the graph look like? This is a square root. So it looks like that. This first step is always identify what the end result looks like. And so it looks like that. Now we need to work with the numbers. And I usually start on the end. So this negative 8 is on the end. And numbers on the end, move it up and down. And so in this case, it's negative. So it's going to move it down 8 units. And then we've got a positive 2. Opposite of what you think it should do. You should think it should move to the right, but we're actually setting it to 0 and moving it over. So it's actually going to move it back to the left. I always like to write our ordered pair where we begin. And so we're going to start now at negative 2, because we're having to move back 2 units, comma, negative 8. So we're going to start at negative 2, negative 8. So let's plot our point, negative 2, negative 8. So it's going to be way down here, and that's going to be at about -2, -8. Now, what are we going to do? Well, the number in front is that 1, so we're going to have to go up 1 and over 1. So here's my starting point at -2, -8. We're going to go up 1 and over 1. That makes our new dot, and we want it to look like this. So we've got those two dots, so we connected together, and there's our graph. Now, do we have to worry about anything over here? No, because the square root graph doesn't have anything back to the left. So I'll give you a moment to kind of digest that. So what did we first do? Let's talk about our steps here. First step was we figured out what the graph should look like. Okay, so it's going through those basic graphs and finding the one that matches. And we draw it over to the side so we have an idea of what it should look like. Then we started with our translations. And so I always like to work on the end and then move to the operation. So that -8 is on the end. So that moved it down 8 units. That 2 is positive. It's inside the operation, so it moved it forward. Sorry, it's positive, so it moved it backwards 2 units. Negatives move it forward. Positives move it backwards. Opposite of what you think it should do. There was no number in front, so that means we use a 1. So that gives us a 1 over 1. So then we plotted our point, -2, -8, connected them together by going up 1 and over 1 with that curve. And that is our graph there. We'll do one more of these, and then we're going to look at the greatest integer. And then once we're comfortable with that, then we'll learn how to take a graph and come up with our equation. So that'll be one of the last things that we do, and then we'll look more at translations. Let's do one more of these, and then we'll look at the greatest integer. So let's try and graph f of x equals, how about -2? Out in front, we'll use an x plus 4 cubed, and then we'll do a plus 5. Okay, so first thing we do is we identify the fact that this operation with that x is a cube. So we look at our pictures in the back cover of our book, and we find the cube. And the cube looks like this. So our graph should resemble that at the end. Then we identify our translations. 5 is located on the end, and it's positive. So that moves it up 5. The 4 is on the inside, and that is positive, so that moves it back 4. Again, left and right is opposite of the way you think it should go. That's the way I remember it. Opposite of what you think it should do. And what about that 2? That -2 is going to be a -2 over 1. Okay. So now let's go ahead and find out where we start at. And where do we start at? Well, we start at, moving it back, -4, +5. So that's where we're going to begin. So we're going to begin at -4, +5. So we'll plot that point. right here at -4, +5. The number in front was a -2/1. So that means we're going to go down 2, and then we're going to go over 1 unit. So from our original starting point, we go down 2. That should be right about there. So we're going to go down 2 and over about 1. Make our dot, connect it together. We need to get the other side. So how do we get the other side? How do we make it look like this? We don't want it to curve down here. We should have it curve up here. So to make the graph look right, we go back to our point, -4, +5, and we're going to have to go up 2 and back 1. So now we go up 2, and then we go back 1 unit. Make our second dot, and now we can connect them together, and that makes our cubic graph. The one function that we haven't talked about is the greatest integer function. And the greatest integer function looks like a case of stairs. And these are going to be the greatest integer bars. So we'll look at the picture of the greatest integer function here. Some textbooks call this the floor. So here's our greatest integer function, and it looks like a case of stairs. So it needs to look and resemble a case of stairs. And these are greatest integer bars. It's easy to get them mixed up with the absolute value. But these are going to be greatest integer bars. And what the greatest integer does is it makes you round down. So the greatest integer is always going to round down. Now, we use the greatest integer all the time. If you go and, let's say, rent a movie from Redbox, and let's say you go rent a DVD from Redbox. If I turn that movie in early, do I get my money back? Do I get any extra money for turning it in early? No. But what happens if I don't turn it in on time? Charge another day, right? It doesn't matter whether I'm 20 minutes late or 5 hours late. I'm charged 2 days. So greatest integers make a case of stairs, and what they do is they stay at a fixed level until a certain time where it goes up to the next one. So that's like renting a movie. When you rent this movie, bring it back early, you don't get your money back, but you don't turn it in on time, what happens? You're charged the next day. So it makes kind of a case of stairs. And the greatest integer graph looks like this. Our function is the greatest integer. And it looks like a case of stairs. And it has these open and closed circles. And when we work with the greatest integer, we always start here with a closed circle. So when we go to graph this, we're going to start with that closed circle. And then we're going to make a case of stairs. If it's positive, it goes up. If it's negative, it goes down. So we'll do probably 2, maybe 3 of these if we need to. But it needs to make a case of stairs. let's start with this. Let's try and graph now. 3 times the greatest integer of x. So we know it needs to make a case of stairs. So it's going to look like this. So we know it needs to make a case of stairs. Is there any number on the end? Nope. Is there any number inside the greatest integer bars? Nope. So no numbers on the end, no numbers inside. So where are we going to start at? Well, we're going to start at 0, 0, because there's nothing on the end, nothing inside. So we're going to start at 0, 0. And then what about that 3? Well, again, that 3, what does that do? That means we go up 3 and over 1. So we start at 0, 0 with a closed circle. And then what we do is we go up 3 and over 1. Make another closed circle. Up 3 again, over 1 again. Make another closed circle. And then we can get some going down as well. So to get those, we go down 3, back 1. Make a closed circle. Down 3, back 1, make another closed circle. It needs to look like this. So we just connect them together. And the open and closed circles are on top of each other. So we make an open circle down below, and it goes up to the next line. Closed circle, and it should be right on top of that open circle here. So we have an open circle here. And these are kind of difficult to draw, but you want the open circle to be pretty much on top of the closed one. So what did that 3 do? All that 3 did was, instead of it being like this, it's 3 times as tall. So case of stairs, instead of going up 1 and over 1, you went up 3 and over 1. Let's try one more, and then we'll take a real quick break, come back, and try to finish this up. Make sure I cover everything I need to cover here. So let's do one more of these. And let's try and graph now. F of x equals the greatest integer of x minus 2. What does it look like? Well, it needs to look like a case of stairs. And that negative 2, that's on the end, and it's negative, so that means we go down. There's no number in front, so we'll put a 1 here. And what does that 1 mean? That 1 means we go up 1 and over 1. Where are we going to start at? Down 1 unit, so that means we're actually going to start at 0, negative 2. So that's where we're going to begin. So we'll start at 0, negative 2. And we always on these start with a closed circle. So we'll start at 0, negative 2 with a closed circle here. And then what do? Up 1, over 1. So up 1 and over 1, make a dot. Up 1, over 1, make a dot. up 1, over 1, make a dot. And you just need a few of these, so a couple in each direction. How do we get the left-hand side? We do the opposite, so we go down 1, back 1. Down 1, back 1. And then we just connect the open circles below with straight lines just like this. And there's your graph. So what did we do? Well, the only thing that we did to our graph was we shifted that staircase down 2 units. So we're going to now take a real short break. We'll come back and we'll finish up 2.7 because that's what we've worked on so far. Part of 2.6, we'll finish it next time, and then that'll be it for today. So we'll take about a 5-10 minute break. We'll probably try to take a 10-minute break, come back, and then we should have enough time to finish up this part. We'll talk about piecewise defined functions next week.